Okay, this is a summary of ionic bonding, just very brief, very quick. There's other videos on the channel that will give you a bit more detail. So what we've got ionic bonding, it's got some examples here of compounds that contain ionic bonds. We have to remember that ionic bonding involves a reaction between metal atoms and non-metal atoms. Metal atoms are on the left of the periodic table, non-metal atoms on the right of the periodic table. And we must remember that metal atoms are looking to lose electrons. So here's an example where sodium is going to lose its electrons. If you lose electrons that have a negative charge, then you are going to form a positive ion. Non-metals are the opposite. They're going to gain electrons. When you gain electrons, you are going to become negatively charged. You form negative ions. Here's an example of chlorine. Chlorine is going to gain the electron from sodium, and it's going to form a negative ion. That means that these electrons are being transferred from the metal to the non-metal. The ions that form have got opposite charges, and opposite charges attract, and those attractions are called electrostatic attractions. And from this, we form an ionic lattice. In terms of the transfer, I've already said metal transfer to non-metals. Here it is in visual. So here's my sodium. Sodium's got one electron in the outer energy level, so it's 281. And that's going to be transferred to chlorine, which was 287. This is going to make the sodium stable, and it's going to make the chlorine stable. Sodium has lost its electron, so it forms a positive ion. Chlorine has gained the electron, forms a negative ion, and those two charges attract because they are opposite charges. And that is the electrostatic attraction. In terms of how this works, you should be able to work out the formulas for these compounds using the bonding rules. So the group number, the ion they form, how many bonds they want to make, and then you should be able to work out each of those. There's a video on the channel that gives you examples of how to do that if you're stuck. This structure then leads up to this. We've already mentioned the Ionic Lattice. The Ionic Lattice contains opposite charged ions next to each other, so positive, negative, to build this 3D structure. In here you can see these little lines representing those electrostatic attractions that hold the ions together. So this is in a solid state. Some key properties for this. So melting and boiling point for ionic compounds is high because these electrostatic attractions are strong. That means they take a lot of energy to break them, and to melt them we have to break them, and therefore the melting point is very high. In terms of electrical conductivity, then as a solid, it doesn't conduct because the ions are held in place. They can't move. These electrostatic attractions in the lattice hold it in place. In order for us to help this to conduct, we have to either heat it up to make it molten, to break all the bonds, or we drop it into some water to make a solution, and that will cause the lattice to break, and therefore the ions are free. When the ions are free, it will conduct electricity. So as a molten or solution, it will conduct electricity. And remember, linking it to electrolysis, we call that then an electrolyte. So that's a quick summary of ionic bonding. I'm going to do the same for the other types, so you can watch them all and get a couple of minutes revision of each one.